Welcome, everyone. Answering an exam question is one thing, but what if you could actually think like the person who's marking it? Well, that's exactly what we're going to do. We're going to deconstruct an AQA question and get right inside the mind of an examiner by looking at the official mark scheme.
So here's our plan for this 10-mark question. We'll unlock the mark scheme, look at tests for sodium and chloride ions, analyze the method, crush that big calculation, and wrap it all up by thinking like an examiner. Let's jump right in. Okay, so our challenge today is question 1 from the AQA GCSE Chemistry Higher Tier Paper 2. Let's get into it. We're going to go through this question step by step, and for every single part, we're going to have the official mark scheme right by our side. It's like having a cheat sheet that tells us exactly what the examiners want to see to give you those top marks. First up, we've got question 01.1. This is a classic 2-marker on identifying positive ions, a really good place to pick up some early marks. Okay, so notice it's asking for 2 things. You've got to describe the test, and you have to give the result. It's a classic 2-part question, but here's something really interesting. The mark scheme actually gives 2 totally valid ways to answer this. So you've got options. So option 1, and probably the one that jumps into most people's heads, is the flame test. It's super straightforward. You do the test, and you get a bright yellow flame. That's it. 1 mark for the test, 1 mark for the result. Easy peasy. But wait, there's more. You could also go with flame emission spectroscopy. It's a bit more high-tech. If you write this down, the key for the result is seeing that the lines on the spectrum match the known spectrum for sodium. Both answers get you full marks. It's good to know you have a choice, right? All right, so that's the positive ions sorted. Now let's move on to question 01.2, which is all about the negative ion. And for this one, you really have to be precise with your language. Just like before, it's a 2-part answer for 2 marks, test and result. But this time, the mark scheme is super specific about the chemicals you mention. You can't be vague here. So what's the test? You need to add acidified silver nitrate solution. And the result? You get a white precipitate. Now that word acidified is really important. Why? Well, you add the acid to get rid of any pesky carbonate ions that might be hanging around, because they could also form a precipitate and totally mess up your result. So acidified silver nitrate gives you that classic white precipitate. That's what they're looking for. Okay, we're shifting gears now. We're moving away from just identifying things and into understanding the method of an experiment. It's not enough to know what to do. Examiners want to know that you understand why you're doing it. So question 01.3 is a 1-marker, but it's a crucial concept. Why do you keep heating and reweighing until the mass stops changing? It's simple, really. You're trying to make sure every last drop of water has evaporated. If you just heat it once, how do you know it's all gone? You don't. But if you heat it, weigh it, heat it again, and the mass is the same, boom. You know you've driven off all the water, and you're just left with the dry salts. Next up is a multiple choice question. This is basically a logic check to see if you were paying attention to the experimental method. How do you actually figure out the mass of the salt you're left with? And here's the answer. It's exactly what you'd think. You take the final weight, that's the dish plus the dry salt, and you just subtract what the dish weighed when it was empty. The difference is, of course, the mass of your salt. Makes perfect sense. Okay, here we go. This is the big one. Question 01.5 is a 4-mark calculation, and this is where you can really show off your skills. And I can't stress this enough. You have got to show you're working. And you're gonna love this. The mark scheme actually gives 3 different ways to get to the right answer. That's amazing! It means as long as your method is chemically sound, they'll give you the marks. So let's look at all 3, starting with the most direct route. Okay, method number 1. First, you calculate the mean, or the average, concentration of the sodium chloride. Just add up the 4 results and divide by 4, which gives you 35.0. Simple. Then, step 2 is to find 39.3% of that number. And that's it. That gives you the mean concentration of the sodium ions. Now for a different approach. With this one, you start by adding up all the concentrations to get a total. Then, you calculate 39.3% of that big total number. The final step is to take that result and divide it by 4 to get the mean. See? You're doing the steps in a slightly different order, but you're heading to the same place. And finally, method number 3. This one kind of flips things around. Here, you calculate the sodium ion concentration for each trial separately. So you'll do 4 little calculations. Once you have those 4 numbers, you just find the average of them. Add them up, divide by 4.
And what do you know? Whichever of the three paths you take, you land on the exact same answer, 13.8 grams per decimeter cubed. 4 marks in the bank? That's the beauty of it. There's more than one way to be right.
Okay, so let's pull all of this together. After going through that whole question with the mark scheme, what are the big takeaways? What have we learned about thinking like an examiner? Look, the bottom line is this. You've got to use precise language like acidified silver nitrate. You have to show your working and calculations, always. It's also super important to remember that there can be multiple right ways to get to an answer. And please, please read the question carefully. If it asks for a test and a result, give them both. Ultimately, it's not about memorizing facts, it's about understanding the why behind everything and communicating that clearly. That's what gets you the top marks. Once you start thinking this way, it's a real game changer. You're not just doing chemistry anymore, you're learning the skill of acing exams. So, what do you want to tackle next? Let us know which AQA question you want us to break down in the next explainer. We're ready for the challenge.